Hi, everybody. It's Mrs. Hutto here, ready for a lesson about thinking spatially. Today, we're looking at what are maps and how do we use them. Geography is the why of the where. When we study geography, we ask questions about places. And maps are a great way for geographers to show what they know about an area, whether it's the whole world or just a tiny county. The map is the where of geography, and it allows us to draw conclusions, make connections, and ask questions. So what is a map projection? That's the first thing we need to know. A map projection is the way we fit the Earth's three-dimensional surface onto a flat paper or screen. So the Earth is round, and it's 3D, and a map is 2D. That's going to lead to some problems. There are problems with map projections, such as shape, distance, relative size, and direction. This is called map distortion. Think about when you peel an orange. You can't just lay it flat. It doesn't have the same shape. You cannot recreate the 3D circle by laying it flat. And that's the same thing with a map. So we encounter a lot of different issues. Cartographers make different maps for different reasons. So some map projections are very accurate in some ways, but inaccurate in others. There's no one perfect map. The closest we have is a globe, and that's really hard to carry around, so that doesn't quite work either. I want you to watch this video. It's a great video about map distortion.
Use Merriman. Yes. Should we begin?
Yes. Plain and simple, we'd like President Bartlett to aggressively support legislation that would make it mandatory for every public school in America to teach geography using the Peters projection map instead of the traditional Mercator.
Give me $200 and it's done.
Really? No. Why are we changing maps?
Because, CJ, the Mercator projection has fostered European imperialist attitudes for centuries and created an ethnic bias against the Third World.
Really?
The German cartographer, Mercator, originally designed this map in 1569 as a navigational tool for European sailors.
The map enlarges areas at the poles to create straight lines of constant bearing or geographic direction.
So it makes it easier to cross an ocean.
But
Yes.
it distorts the relative size of nations and continents.
He's talking about map.
Are you saying the map is wrong?
Oh dear, yes. Look at Greenland.
Okay.
Now look at Africa.
Okay.
The two land masses appear to be roughly the same size.
Yes.
Would it blow your mind if I told you that Africa is in reality 14 times larger?
Yes?
Here we have Europe drawn considerably larger than South America. When it's 6.9 million square miles, South America is almost double the size of Europe's 3.8 million.
Alaska appears 3 times as large as Mexico, when Mexico is larger by 0.1 million square miles.
Germany appears in the middle of the map when it's in the northernmost quarter of the Earth.
Wait. Relative size is one thing, but you're telling me that Germany isn't where we think it is?
Nothing's where you think it is.
Where is it?
I'm glad you asked. The Peters projection.
It has fidelity of axis.
Fidelity of position.
East-west lines are parallel and intersect north-south axes at right angles.
What the hell is that?
It's where you've been living this whole time. Should we continue?
Uh-huh.
All right, so there are lots of different map projections. The first one we're going to look at is the goods projection. This is known as an interrupted map or a global gore. The ocean's interrupted. This is most like the orange peel. This means the points on the two edges are really supposed to be right next to each other, but not on this map. Antarctica's interrupted. It's not in 4 separate pieces for real. We know this. Because oceans interrupted, the landmass actually looks bigger than the oceans, which is not correct. The plus side to this projection is that landmasses, their sizes are appropriate. Africa is much larger than North America and South America, which is correct. And the shape is not of these different continents are not very distorted either. So that's a really good positive. Now, the Mercator map is the one they were complaining about in that video. It's great because it has perfectly straight latitude and longitude lines. It gives the map a lot of pros and cons, though. The Mercator projection has good direction. It's one of the best maps to use if you are trying to navigate somewhere. Now, we have GPS, but before GPS, we use maps like this. And landmass shape is accurate in this projection, which is really important. However, the distance in the lines of latitude at the poles compared to the distance to the equator is wrong. This causes huge size distortion, especially in the polar regions. Antarctica is not nearly that big. And direction is accurate, but distance is very distorted. So the distance isn't quite what we need it to be to really understand how far apart things are located. Now, this is an equal area projection. So this is correct, and this is what they were looking at on the video as well. In an equal area projection, size is accurate, which is really important, but the shapes are not correct. So, I mean, look at North America. Because it's, and Asia, the shape is not correct at the top. It's more correct at the bottom. Antarctica is not really that flat. That's an issue too. So in the polar areas in the far north, you get the shape is wrong. Now, this is the Robinson projection. You've probably seen this a lot. It's pretty. And it's used for thematic maps. It's informational maps. Size and distance accuracy is not great, but it's easy to read, it's easy to understand, and it's great for just learning, okay, where countries are and things like that. Maps are used to give information. There are different types of maps that work for different types of information. You have political, physical, and special purpose maps. So this is a political map. It shows government division of land areas. So this map in particular shows country divisions. It's not going to show physical features. It's just here where the countries are. Now, this is a physical map. A physical map shows the physical features of the land, like mountains and rivers, deserts, plateaus, things like that. We also have special purpose maps. This map is called a choropath map. And a choropath map puts features into classes and then maps the classes for each region. So I might use this map if I'm thinking about moving and I want a large population of people ages 20 to 24 because I want to be around young people. I'm going to look for areas on this map with the darkest red because the most young people, young adults, are going to live in that area. This is an isoline map or a contour map. They connect points of equal value. Now, the map on the left is different ethnic groups, and the map on the right shows elevation. They're both important these are both really useful tools in geography. All right, now this one is a proportional symbol map. It's the size of the symbol corresponds to the magnitude of the mapped feature. So the larger the circle, the more plane crashes there have been in the past from 1945 to 2016. Notice that Russia and the United States have the most. And that a lot of that is because of the Cold War during most of that time. All right, so summing it up, I hope you can see what we mean by thinking spatially. It's much easier to use a map to show information about geographical regions than it is to write an essay. We're going to be thinking about data a lot in this class and how it corresponds with different places. So make sure you remember these maps and have this video to look back on.